Welcome to Stoichiometry problem. So this is 2025 and we just want to analyze the sort of question that was asked in 2025 final exams. So the question reads, this is section B. 4.00 grams of impure iron 3 oxide, reacted with 600 centimeter cubed of 0.100 mole per deciliter cubed of sulfuric acid. The first question is requiring us to construct the balanced chemical equation for the reaction. And in the bracket is saying state symbols are not required. So now we want to construct a well-balanced equation for this particular reaction that occurred. This is iron 3 oxide, which is going to react with sulfuric acid. Okay. So what products are we going to get when we react iron 3 sulfate with sulfuric acid? Okay. So basically, let me just use somewhere else because the question the space there is not adequate enough. So I'm going to use this bracket, this box here. So we are saying iron, this is iron 3 oxide. So the formula for iron 3 oxide is going to be iron 3 oxide. So this is iron 3 oxide. For those who don't know how to form a chemical formula, let me just explain a bit here. So if we have iron 3 oxide, we mean 3 is the valence, and then we are having oxygen who is going to have 2 valence. So we tend to swap these values. That's why we are going to have this formula as iron 3 oxide. So we have iron 3 oxide there reacting with sulfuric acid, and we know that sulfuric acid is H2SO4. So if we react iron 3 oxide with sulfuric acid, what products are we going to get? The products that we are going to get the same iron 3. We are going to get iron 3 sulfate plus water. Okay, so we are going to have iron 3 sulfate, and then this is going to combine with this to form water. So that's how the equation is going to be. So we are going to have the equation of the kind as iron 3 sulfate. Okay. So for those who are wondering how this equation has been formed, we are talking about iron 3 and sulfate is a radical which has 2. So we are just going to swap these numbers, and then we are going to have iron 2, then open bracket, then iron 3, yes, iron 2, then 3 outside. So this is how we are going to get iron 3 sulfate. And then plus water. So now we need to balance this particular equation. How are we going to balance this particular equation? We are just going to look at the coefficient. Okay, we want to look at the molecules, or rather atoms, of each and every element here. So how many atoms of iron do we have, and how many atoms? Because in stoichiometry mostly we deal with we look at reactants should balance with the products. So we want to assess if all these elements are having the same number of atoms in the reactant as well as in the products. Basically, this is due to the principle that when an atom exists, it can never be created or destroyed. So it should have the same amount in the products as well as the reactants. So now let's try to balance this equation up. Let's look at iron. We have 2 molecules of iron on this is the reactant, and then we have 2 molecules of the ions with the product. So this is balanced. Okay. Then when you look at the molecules of oxygen, we have about 8 molecules of oxygen, about 7 molecules of oxygen on the reactants, but the products we have about 11. Okay, 4 times 3, that's 12, plus 1, that's 13. So now, how are we going to balance the molecules of oxygen? Okay, how are we going to balance the molecules of oxygen, because they are different? I believe with the amount of hydrogen as well, there's with hydrogen it's just okay. So how are we going to balance this equation? Balancing an equation is simple. In case you want to know step by step on how to balance an equation, you can actually review some of my tutorials on balancing of the equation. So this equation is going to be balanced by putting 3 here, and then by also putting 3 on the molecule of what? Of sulfuric acid. Okay, because with iron is already well balanced. So this is how the balanced equation for this particular question is going to look like. We can just rewrite it. The balanced equation is going to look like iron 3 oxide plus 3 sulfuric acid to produce iron 3 sulfate plus water with 3 here. Okay, so now this is all coming from the concept that in stoichiometry we deal with the reactants and the products, so they need to be well balanced. Okay, they need to be well balanced. A balanced chemical equation is more like a recipe, because we want to add the reactants and then we see the products. So everything together is going to form this particular equation. So that is going to be our balanced equation in this situation. So now the question is requiring us, now we go to B. B is requiring us to calculate the mass of pure oxide that reacted with the acid. The amount of pure oxide that reacted with the acid, because that one was impure. So with that volume and concentration that we are given, we can find the amount of pure oxide that reacted with the acid. So now, one thing you should know about stoichiometry when you are calculating, when you are solving issues involving stoichiometry, there are some few things that you should know. Basically, simple steps for you to deal with stoichiometry matter. So, whenever you are dealing with stoichiometry, first thing you should be able to write a well-balanced equation, and then with this well-balanced equation, you have been given parameters on top there. You can use those parameters so that you can find the number of moles of those particular known substance. For example, like sulfuric acid is having the concentration, is also having the volume. So you can actually use that particular numbers to calculate for unknown moles. Okay, and then we usually use the mole ratios, because in the reactant and the product, in the reactant mostly, you are going to they are what we call mole ratios. Mole ratios are going to be used once you balance the equation to calculate the unknown moles that are in the equation. And then you can convert now these moles using different formulas to calculate, to find what you want. For example, your formula is like mass is equal to moles times molar concept. Okay, so basically like that. So now let's solve this issue here. We shouldn't forget our balance equation. we are going to write it down here. So our balance equation, from our balance equation, that's where we're going to get all the answers. So it is iron 3 oxide plus this is our balanced equation, and these were the reactants, and then because the space is not adequate, so we're going to have the product, which is iron sulfate plus H2O, water. So please bear with me, this is the balance equation. So we want to find the mass of a pure oxide that reacted with the acid. So what are we going to do? First of all, let's use the known values. We have the values for sulfuric acid. Okay, so we can calculate the number of moles for sulfuric acid because we are given the concentration and volume. So these values, we are going to keep them. So for sulfuric acid, forgot H2. So for sulfuric acid, we can calculate the number of moles. Moles is equal to concentration times volume. We've been given the concentration and volume, except that the volume is in 600 centimeter cube. Now in stoichiometry, we always want to find the volume in deciliters. Okay, so what are we going to do? We need the volume, the volume in decimeters. So we are going to divide, we say 1000 centimeter cubed is equal to 1 decimeter cubed. So we're just going to divide this 600 centimeter cubed by 1000 so that we can get the deciliter cubed. So the concentration we have there is 0.100 moles per decimeter cubed, and then multiplied by the volume. The volume that we have converted, that is going to be 0.6, right? So if we want, here we want to calculate, we want to find the number of moles. What is the number of moles that we are going to get when you multiply this? You can get your calculator. I'm also punching here. So when you multiply 0.100 times 0.6, we are going to get 0.0600 per mole. So this is the number of moles of sulfuric acid. So we are going to write it somewhere because we need the space. So 0.06 moles is the number of moles for sulfuric acid. If we find the number of moles for sulfuric acid, I'm going to lab here because the calculation is still there. So that was the first step. We balance the equation, and then for us to find the mass of a pure oxide, because the oxide has not been given parameters, so we need to first calculate the available moles for sulfuric acid. You see how this is going to go. Okay, so if we find 0.06 moles of sulfuric acid, okay, this is sulfuric acid, we can now use the mole ratios within the equation for us to calculate the number of moles for what? For iron now. Okay, so when you look at the mole ratio, the combination, like the reactants that we are having, with iron oxide, we have the mole ratio of 1. So when we are trying to get the mole ratio, we just look at the coefficient of that particular reactant. So the coefficient here is 1, and then the coefficient for sulfuric acid is 3. So this is basically 1, 2, 3. So this 1 to 3 mole ratio is going to be used for us to calculate the number of moles for iron 3 oxide. How are we going to do that? We are just going to say, if this is iron to sulfuric acid, okay, sulfuric acid has 3, and then this one has 1. And then what is the number of moles for sulfuric acid? This one we calculated here, 0.06. And then how about iron? Iron is X. We are looking for the value of X. So we cross multiply, and then 1 by 0.06. So this is basically like for us to find the number of moles for iron. The number of moles for iron 3 oxide, we'll need to 1 times Z, then we're going 1.006, then X times 3, that is basically 3X. So for us to find X, because X is the number of moles for iron 3 oxide. So if this is basically like we are dividing by 3, so X and X, 3 by 3 goes, then we say X is equal to 0.06 divided by 3. What answer are you going to get when you punch on your calculator? You are basically going to get the answer of 0. You are going to get the answer of 0.02 moles. So now you have the number of moles for iron 3 oxide. You have the number of moles for iron 3 oxide. But what we are basically looking at, we are looking at the mass of iron oxide. So you can now find the molar mass of iron 3 oxide. Okay? We are going to keep these values. Here is going to be for calculation. So we can calculate the molar mass for iron 3 oxide. Iron 3 oxide. The molar mass is simple. When we look at the atomic mass of iron is 35. So we have 2 atoms. So it is 2 times 35. No, not 35. It's basically 56 actually. Okay. So it is 56 plus, when we look at the mass number for oxygen, that's basically 16. So we are going to multiply 3 by 16, meaning we have 3 atoms of oxygen multiplied by its mass. So when you multiply this, you add, you are going to get the molar mass of about 160 grams per mole. So this 160 grams per mole, this is now the molar mass of iron 3 oxide. So since the sulfuric acid just helped us to find the molar mass of iron 3 oxide, we can lab it off, and then we are going to remain with iron 3 oxide molar mass, which is 160 grams per mole. We have calculated this 160 grams per mole. Now that we have the molar mass, and we have the number of moles, we can calculate for the mass of iron 3 oxide. How are we going to calculate that? We just use the formula. Mass is equal to moles times molar mass. Okay? Because this formula is also can be used to interchangeably, where you can make moles the subject of the formula. When you make moles as the subject of the formula, it means moles is equal to molar mass divided by mass. So the mass of iron 3 oxide is going to be calculated using the moles. How many moles do we have? We have 0.02 multiplied by what is the molar mass? We calculated it to be 160. So get your calculator and then find the mass for this particular. So when I punch on my calculator here, I'm getting the answer to be 3.20. And remember, this was moles and then this was mole. This was grams per mole. Okay, so moles and moles are going to go, we are going to remain with grams. And this is basically how you are going to calculate the mass of pure oxide that reacted with the acid. The steps are simple, you just follow them step by step. So stoichiometry is all about writing a balanced equation, finding the number of moles of known substances, and then use the same mole ratios to find the substances that are not, you find first the substances of known. For example, we had sulfuric acid with known substances. We calculated, then use that mole to calculate the mole of that unknown substance. After calculate the mole of that unknown substance, that substance you can use now, you know the molar, what is the molar mass of that substance. So once you calculate the molar mass, then you basically just use the formula mass is equal to moles times molar mass. Then you come up with the mass, which is going to be like this. This is basically how we deal with stoichiometry question. Please follow for more stoichiometry questions.